Questions 11 through 20 on the 2005 Grade 10 AMC 10B. The first term of a sequence is 2005. Each succeeding term is the sum of the cubes of the digits of the previous term. What is the 2005th term of the sequence? So we got term number 1 is 2005, and then term number 2 will be the sum of the cubes of the digits of the previous term. So that will be 2 to the power of 3 plus 0 to the power of 3 plus 0 to the power of 3 plus 5 to the power of 3, like that. So this is 8 plus 125, and therefore that is 133. And then the third term is again the sum of the cubes of the digits of the previous term. So that's 1 to the power of 3 plus 3 to the power of 3 plus 3 to the power of 3. And that's 1 plus 27 plus 27. So that is 55. And then we just keep going like this. Fourth term is the sum of the cubes of the digits of the previous term. So that's 5 to the power of 3 plus 5 to the power of 3. And that's 125 plus 125. And that is 250. All right, let's keep going. Hopefully there's a pattern here. The fifth term, I guess I can squeeze it here. 2 to the power of 3 plus 5 to the power of 3 plus 0 to the power of 3. 8 plus 125, and that's 133. Okay, perhaps this is a pattern. Let's just do one more. Let's see what happens. 1 to the power of 3 plus 3 to the power of 3 plus 3 to the power of 3 equals 1 plus 27 plus 27, and that's 55. So there you go. This sort of just repeats. 133, 55, 250, 133, 55, 250, and so on. So basically what that means is that we have to figure out where in that pattern is 2005. So first term, second term, third term, fourth term, fifth, sixth, seventh, and so on, eighth, ninth, all the way up till the 2005th term. So the first term is sort of all by itself, right? But then you've got 133 and 50, 55, and then 250, and then again 133, 55, 250, and so on, right? So we have to figure out where does the 2005 lie. Well, let's see. It seems like every time the term is a divisible by 3, it'll be 55. So is 2005 divisible by 3? And the answer is no. 2005 divided by 3 is 668.3, like that. Okay, so it's not 55. Well, obviously it won't be 2005, so it'll be either 133 or 250. We just have to figure out. If you take the term number and subtract 1, like for example 4 subtract 1, it should be divisible by 3, correct? 4 minus 1 is 3, and 3 is divisible by 3. So let's see if 2005 subtract 1 is divisible by 3. So that's 2005 minus 1. It is exactly 668. So there you go. So that means that 2005 is the same as these guys. It'll be 250. All right, so you just have to find a little bit of a pattern there. So therefore 11, the answer is E. 12 fair dice are rolled. What is the probability that the product of the numbers on the top faces is prime? So we have 12 dice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And obviously they're fair dice, so the numbers on the top are going to be anywhere from 1 to 6. It's just a regular dice. Die is singular, and dice is plural, I think. So what is the probability? Okay, well, in any probability question, what I like to do is immediately figure out the denominator, which is the total possible combinations. So for each of these, there's 6 possible combinations, right? 1 through 6. And again, 6 and 6. So it's basically 6 to the power of 12. That's the denominator. So now we have to figure out the numerator, and the numerator, of course, is what we are interested in with regard to the criteria in the question stem. They want the product on the top to be prime. Okay. Well, how on earth would we get a prime number if you're multiplying a whole bunch of numbers together, right? The whole definition of a prime number is that it's divisible by only itself or 1. Well, if they're all 1s, if every time you roll it turns out to be a 1, then that might work, all 1s. If you have all 1s, the product will be 1, but 1 is not a prime. 1 is not a prime number. So even though that seems like a way to go, it's not one of the answer choices. Okay, no problem. How about if all of them are 1 except 1 digit? So all 1s except 1. So that basically means 11 1s. 11 1s, I'll write out the word 1s. And then one of the numbers is a prime. That would work. So we have 11 1s and a 2. And a 2. Right? Because if the 2, for example, is here and these are all 1s, the product will be a 2. Does that make sense? So that means the product is a 2. And is that a prime? Yes, it is. How about 11 1s and a 3? That would work, right? Because 3 is another prime number that's possible in terms of the dice. And that would result in a product of 3. That also works. 4 won't work because 4 is not a prime, right? 4 is divisible by 2. 5 works. 11 1s and a 5. And 6 won't work because 6 is not a prime. It's divisible by 2 and 3. So I've got 1, 2, 3. 3 over 6 to the power of 12. Is that the right answer? No. I don't even think it's part of the answer choices. Yeah, I don't think it is. Now you say, well, why? What's the problem here? I mean, well, this makes sense. Because the reason 3 is not the proper numerator is because where each of these scenarios, it can happen in many different ways, right? The 2 can be here and then you can have all 1s, right? Or the 2 could be here and you can have all 1s, and so on. So for each of these, you've got 12 possible ways of that happening. The 2 could be any of these 12 positions. 2 could be here, and so on. I mean, you get the point. So in total, we don't have 3. We have 12, 12, and 12, 36 ways of doing this. So that is the numerator. All right? Now, 36 over 6 to the power of 12 is not one of the answer choices in that exact form. So no problem. This is a good question because it illustrates something that happens on math contests where you get the answer, but it doesn't look like any of the answer choices. You just have to put it in a different format. So let's see, how can I do that? 6 is itself 6 to the power of 2. All right, 6 to the power of 2 over 6 to the power of 12. That means 1 over 6 to the power of 10. Now, is that one of the answer choices? And it is. That's 12E. So there you go. How many numbers between 1 and 2005 are integer multiples of 3 or 4, but not 12? First, let's just concentrate on this part right here. Integer multiples of 3 or 4. The rest we'll worry about later. Well, I like this question because this question comes up a lot, this type of question. So I'm going to give you very basic. Instead of 2005, I'm just going to go until 12. I'll explain it, and then we'll come back to this question because this needs to be understood fully because it will come up again and again. Let's say I said between 1 and 12, how many integers are multiples of 3 or 4? Well, you can just look at it and do it. Say, well, integer multiples of 3, I've got 3, 6, 9, 12. integer multiples of 4. I've got 4, 8, and 12. So I've got, counting them, 1, 2, 3, 4, 5, 6. I've got 6, no problem. Yeah, because there's only 12 numbers. But if you have 2005, you obviously are not going to write them all out. So there's got to be some sort of a pattern or some sort of a system, a better way of saying it. And there is. What you do is you take the number that is at the very extreme, which in our case is 12, and first you say, well, how many multiples of 3? You do that by dividing the number by 3. And in this case, we get 4. All right? So there's 4 numbers that are multiples of 3. In our case, it's 3, 6, 9, and 12. Okay? Then what you do is you take the second part, which is multiples of 4. How do you figure that out? 12 divided by 4, and there's 3 of those. And those in our case are 4, 8, and 12. But you probably noticed that I overcounted. I counted the 12 twice, right? Because it's a multiple of 3 and a multiple of 4. So you have to take away the multiple of 12. And in our case, 12 divided by 12 is 1. That gives me how many multiples there are of 12. So the total is 4 plus 3 minus 1, which is 6, which is exactly what we got by counting. All right? So that is the system. So in a very similar way, we're going to do it for 2005. 2005 divided by 3, and you're going to take the integer value. That's what the symbol means. And that is 668. Then 2005 again divided by 4 to get the number of multiples of 4, and that's 501. And remember, we're overcounting the multiples of 12, correct? And they say, well, I got it, but how did you come up with that number 12? I mean, before it was 12 because there's only 12 numbers, but how did you come up with the number 12 now when we're up to 2005? Because it's 3 times 4. 3 times 4 is basically, if you have 3 and 4, you want the least common multiple. And the least common multiple of 3 and 4 is 12. Okay? So I'm sure you know that from elementary school. So you then would have to take away the overcount. So 2005 divided by 12, and that is 167. So now, just like we did there, 668 plus 501 minus 167, and that is 1002. This is how many are integer multiples of 3 or 4. All right? That's the first part of the question. In our question up here, they want you to also consider not multiples of 12. So they don't want any multiples of 12 at all. All right, no problem. I take my answer that I got, and I subtract from it how many multiples of 12 there are. Got it? So finally, my answer for this question is 1002 minus 167. And that is equal to 835. So that is the answer to number 13, and therefore number 13 is equal to C. Equilateral triangle ABC has side length 2. M is the midpoint of AC, and C is the midpoint of BD. What is the area of CDM? So in this triangle, we'll enlarge it a little bit. And what I'm going to do first is just drop a perpendicular from M down to the bottom like that. Okay? And if you do that, it's helpful to drop another perpendicular down from A all the way to the bottom like that. Okay? And then we just use the information in the question stem that ABC has side length of 2. So this whole side is 2, correct? So that means if I drop a perpendicular, this will be 1. So that will be 1. And then since M is the midpoint of AC, according to the question, this line that I just drew cuts this segment into half. So therefore, from here to here is a half. this segment right there. All right? And that's directly from the question, the information. Now, at this point, to figure out the area of CDM, which is right here, this triangle, I need to figure out the base and the height. The height is right here, so I'll just call that H. And the base, I can use CD. Now they tell me that C is the midpoint of BD. So that means that the distance from B to C is the same as the distance from C to D. Now B to C is 2, so therefore CD is 2. So the area of triangle CDM is 1/2 base, which is CD, which is 2, times height, which I have labeled as H. So that just becomes H. So all I have to do is figure out H, and then I'm set. Okay, I'm going to obviously concentrate on that circled area, circled part of the diagram, which is a triangle. And that triangle I'll draw a little on the side to avoid making this diagram messy. This triangle I'll draw over here, so it basically looks like that, approximately. And this triangle, which is right here, I've drawn on this side here, has some very interesting properties. This is, of course, a right angle, because that was a perpendicular. And this angle is 60 degrees. Why? Because that was an equilateral triangle. And equilateral triangles have 60 degrees as all their angles. And then if we have 160 and 190, and the sum of the angles of a triangle are always 180, this angle is 30. And there you go. You got a 30, 60, 90 triangle once again on a math contest for like the 100th millionth time. And as we all know, the ratio of the sides of a 30, 60, 90 triangle are 1, 2, and root 3. Those are the ratio of the sides, not necessarily the lengths. Now, do we know any of the lengths? The answer is yes. We know this length is a half right here. And therefore, we can figure out H, which is what I labeled that side. So that means H over a half is equal to root 3 over 1. And then if you cross multiply, you get H is equal to root 3 over 2. And there you go. You're done with the question. Area is H, and H is root 3 over 2. So number 14, the answer is C. An envelope contains 8 bills, 2 1s, 2 5s, 2 10s, and 2 20s. 2 bills are drawn at random without replacement. What is the probability that their sum is 20 or more? So we've got 1, 1, 5, 5, a 10, and a 20, and a 20. Now, what I'm going to do is I'm going to call them 1 and 2, since there's 2 of each. To avoid confusion, each of them I'll designate as the first bill and the second bill, like that. So we want a sum of 20 or more. All right, if I take the first 20, if I add any of the other bills, I think I will be able to fulfill the criteria. Correct? So there you go. I've got 7 of those possible ways of doing that. And if I take the second $20 bill, it will be exactly the same. I can fulfill the criteria by adding any of the other bills. And therefore, I've got another 7. All right, let's see if I can keep going here. How about if I take a 10? Can I fulfill the criteria? Yes, by adding 20s, by adding the other $10 bill, and I think that's it. So 3 there. If I take the other 20, it's exactly the same, of course. So that gives me another 3. Any more here? If I take a 5, can I get a sum of 20 or more? If I add the 20s, and I think that's it. Similarly with the other 5, it's exactly the same. And then how about if I take a $1 bill. I would be able to exceed 20 if I add one of the 20s. And I think that's it. That exhausts all the possibilities. So let's count this up. 7, 7 is 14. 3 and 3 is 6, so up to 20. 22, 24, 26, and 28. So I got 28 is my numerator. My denominator, of course, is the total possible combinations in a probability question. For the first bill, I've got 8 possible choices. For the second bill, I've got 7, since 1 has already been taken. So that you have to multiply, and that gives me 56. So there you go. There's my probability, 28 over 56. And in lowest terms, that is a half. So number 15, the answer is D. The quadratic equation x squared plus mx plus n equals 0 has roots that are twice those of x squared plus px plus m is equal to 0. None of m, n, and p is 0. What is the value of n over p? So this is what they want us to figure out. All right, so our first quadratic is of this form, and our second quadratic is got a p and an m in there like that. All right, so the first one I'm going to call the roots R1 and R2, and they're saying that those roots are twice that of this equation's roots. So that means if this has roots R1 and R2, and these roots are double over here, these would be 2R and 2R2 in terms of their values. All right? Now, we know that the sum of the roots of any quadratic or any polynomial is given by a formula, which is minus b over a. And that's for a standard polynomial a x to the n plus b x to the n minus 1 plus dot 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 all the way till z equals 0. The sum of the roots is b over a. So in our case, up here, our b over a is going to be minus m over 1. And that's the sum of the roots, so that's equal to 2r1 plus 2r2. All right, so that's the first part. Now over here on this side, using the exact same formula, this sum, r1 plus r2, is minus b over a, which in this case is minus p. Okay, so what I'll do at this point is I'll substitute this over here. So 2 I'll factor out, and that gives me 2r1 plus r2 is equal to minus m, and then r1 plus r2 is equal to minus p, like this. So 2 therefore is equal to m over p, like that. Okay, so far so good. We're sort of in that category, but not quite. Now, very similar to some of the roots, we also have a formula for product of the roots. And the product of the roots in a polynomial of this form is z over a. And in particular, when it's an even degree. If it's odd degree, it would be minus z over a. Now, do we have even degree polynomials or odd degree? Well, they're just, to the power of 2, so those are just quadratics, and therefore those are even degrees. So we can use z over a. So using z over a, we get the following for this guy right here. Product of the roots is our z over a, in this case would be n over 1, like that. So n over 1 would be the product, and since our roots are 2r1 and 2r2, that would be the product. So this looks like 4 times r1 times r2 is equal to n. And in a very similar way, we'll do the exact same thing on this guy with the product of the roots formula. Product of the roots in that case, if you're using z over a, will be m over 1, And these two, the product is R1 times R2, like that. We can then substitute this into this, and that gives me 4 times m is equal to n. And therefore m is equal to n over 4. And there you go. Now you just plug that into here, and I'll get 2 is equal to n over 4 over p. And this looks like n over 4, invert and multiply, 1 over p is equal to 2. And therefore that means n over p is equal to 8. And that is what we were looking for. 16, therefore the answer is D. Suppose that 4 to the power of A is 5, 5 to the power of B is 6, 6 to the power of C is 7, and 7 to the power of D is 8. What is A times B times C times D? So I just use logs. Do they teach logs in grade 10? I don't even remember. But it's so straightforward with logs that why do anything else, right? So if you take the log of both sides in the first one there, you can bring the A out front like that. And then therefore A just becomes the log of 5 over the log of 4. And when you don't write a base, it is assumed that it's base 10. So this is all base 10, all across. In a very similar way, let's do the next one. Log of 5 to the power of b is equal to log of 6. I just take the log of both sides. And this becomes b log 5 is equal to log 6. And therefore b is equal to the log of 6 divided by the log of 5. In an identical way, we'll keep working with each of these. This becomes the log of 6 to the power of c is equal to the log of 7. And therefore c log 6 is equal to log 7. And therefore c is equal to the log of 7 divided by the log of 6. And finally, we've got this one here. Can I squeeze that in? I'll just do it here. We've got log of 7 to the power of d is equal to the log of 8. And therefore d log 7 is equal to the log of 8. And therefore d is equal to the log of 8 divided by the log of 7. There you go. Now we want a times b times c times d. Okay, no problem. A times b times c times d. Well, this is a, so the log of 5 over the log of 4. B is here, log of 6 over the log of 5. C is here, log of 7 over the log of 6. And finally, D is over here, the log of 8 over the log of 7. Well, you'll notice that things cancel. Those log 5s cancel, log 6s cancel, log 7s cancel, and the only thing you're left with at the end is the log of 8 over the log of 4. Now the log of 8 is basically 2 to the power of 3. Log of 4 is the 2 to the power of 2. And then the 3's and 2's come out, so you got 3 log 2, and the denominator becomes 2 log 2. And then the log 2's cancel. And all you're left with is 3 over 2. And there you go. In a very straightforward way, you get the answer with logs. If there's another way, I'm sure that there is, and you're more comfortable with that other way, then that's perfectly fine, as long as you get the right answer. 17, therefore, is B. All of David's telephone numbers have the form 555 A, B, C, D, E, F, G, where A, B, C, D, and E, F, and G are distinct digits in increasing order, and none of them are 0 or 1. How many different telephone numbers can David have? So 555 is what they use in movies, right? Every time there's a movie and there's a telephone number involved, it's always 555, 555. But in the Coen brothers movies, they refuse to do that, which I like. I'm sure you've heard of these brothers. They make movies, some really, really good films like No Country for Old Men and Fargo and many others. But anyhow, I just wanted to mention that. All right, so here we go with the question. So we've got 7 digits that we've got to fill, right? And how many numbers do we have? Not 0 or 1. So I can only use 2, 3, 4, 5, 6, 7, 8, and 9. And how many? That's 8 numbers. Okay, so I've got to put 7 of these 8 guys in here, but in increasing order. All right, interesting. Okay, I think I can do that. Basically, since I'm using only 7 of the 8, there's always going to be 1 digit not used. Correct? So, for example, let's just use the most basic one, which is just straight across 2, 3, 4, 5, 6, 7, 8. I'm using these as my 7-digit number. The 1 digit not used in this case was the 9. Correct? In this scenario. And in a very similar way, I think, if you don't use 8 and then don't use 7 and don't use 6, 5, 4, 3, and 2, you'll be able to get, a string of 7 other digits in increasing order. That will be possible. And let's see how that works out. So if I don't use an 8, my number will be 2, 3, 4, 5, 6, 7, and 9. Correct? And that is in increasing order. So that's this one. If I don't use a 7, it'll be 2, 3, 4, 5, 6, 8, 9. If I don't use a 6, 2, 3, 4, 5, 7, 8, 9. If I don't use a 5, 2, 3, 4, 6, 7, 8, 9. Well, you get the hang of it by now. 2, 3, 5, 6, 7, 8, 9. If I don't use a 3, 2, 4, 5, 6, 7, 8, 9. And finally, if I don't use a 2, 3, 4, 5, 6, 7, 8, 9. So how many did I get? 1, 2, 3, 4, 5, 6, 7, 8. I got 8 possible ways of making that telephone number with the criteria in the question. So number 18, the answer is D. On a certain math exam, 10 of the students got 70 points, 25% got 80 points, 20% got 85, 15% got 90, and the rest got 95. What is the difference between the mean and the median score on this exam? So let's say there's 100 students. I think that's perfectly allowable. That means 10% of the students got 70. So that means 10 students got 70. And then, according to the question, 25% of the students got 80. So in our case, it's 25 students. 20, 85, 15, 90, and then the rest got 95. So we set 100. So 125, 20, 15, so I've got 30 students left. And now I just got to figure out the median and the mean, and once I do, I can subtract them and get the difference. So the median is, of course, the middle value. If there's 100 students, the middle would be between 49 and the 50. Those two would represent the mean. You'd have to take the average. And let's see here. We got 10 and 25, so that's 35, and then 20 is 55. So one of these guys, and those all get 85 as a score. So that means my median is 85. All right. And now to figure out the mean, which is the average, let's see here. We got 10 times 70 plus 25 times 80 plus 20 times 85 plus 15 times 90 and plus 30 times 95, like that. And then, of course, we have to divide by the total number of students, which is 100. And if you do the math, we got 700 here plus 2,000 plus 1,700 plus 1,350 plus 2,850 all over 100. And this is 86. Median is 85, mean is 86. Subtract them, you get 1. So therefore number 19 is B. What is the average mean of all 5-digit numbers that can be formed by using each of the digits 1, 3, 5, 7, and 8 exactly once? So I'm obviously not going to write all of them out because we got a 5-digit number, right? And we can use these digits. So for the first digit of that 5-digit number, it could be any one of 5 choices. And then 4 choices, then 3 choices, then 2, then 1. Then you multiply them all. And if you do, you get 120. So there's 120 numbers. Now I'm not going to list them all and then add them and then divide by 120 to get the average. So there's got to be some shortcut. Well, if you were to line up these numbers, you had them in front of you and they lined them all up, one on each row like this, correct? And you were going to add them, you know, the long way, the way you did when you first started learning how to add 5 plus 6 or whatever. Remember? Well, 5 plus 7 is 12, or basically back in grade 1. Well, if you did that with these numbers, something interesting happens. These numbers are all composed of 1, 3, 5, 7, 8, right? Every single one of them. So that means 1 appears in the first column several times, correct? Now, how many times does it appear? Well, do you remember how many numbers there are? 120, correct? And if there's 120 numbers, each of those 5 numbers has to appear an equal number of times. So each of them appears 120 divided by 5, which is 24 times. So the 1 would appear, you know, ... 24 times. Okay? And in a very similar way, the 3 ... all the numbers that have 3 as their first digit, the 3 would appear 24 times in the first position. And so would the 5. And so would the, what's the other numbers? 1, 3, 5, 7, and 8, right? 7 and the 8. So there you go. That's how you would figure out the sum. Now each of these columns, it's exactly the same story. The 1 would appear 24 times, 3 would appear 24 times in this column, and the same in this column, and so on. So each of these, when you add it up, will have the exact same sum. So let's first figure out that sum. It would be 24 times 1 plus 24 times 3 plus 24 times 5 plus 24 times 7 and 24 times 8. And therefore that is equal to, a quick way of doing this, 24, factor it out, 1 plus 3 plus 5 plus 7 plus 8. And that gives you 24 times 24. Oh, interesting. And that's 576. Okay. So now we treat this like you treat a addition question in elementary school. Each of these will basically be 576. So if I were to add up this column, all the numbers in it, it would be 576. So I can't put 576 on the bottom. I can only put that number so that I carry the 57. Got it? Then, since this whole thing is equal to 576, I have to add to that the 57. So 576 plus 57 is 633. So the 3 goes here, and I carry the 63. So now I've got to do the same thing, 576, which is the sum of all these numbers, and I've got to add to it what I just carried, which is 63. And that becomes 639. So this is a 9, and then the 63 I carry here. So again, 576 plus 63, so it's 639 again, so the 9 goes here, and the 63, and then finally 576 plus 63, which is 639. So here you go. That's the sum. Now we didn't want the sum. We want the average. Correct? They want the average and the mean. Now how do you figure that out? Well, how many numbers were there? There was 120. So I've got to divide this number by 120. So this number divided by 120 is equal to 5332.8. And let's see which one. That would be choice C. So number 20 is C.